take down the heading. Practical 1. Verification of, write down, take down the heading. Verification of law of parallelogram. Verification of law of vector parallelogram. Take down the heading as verification of law of vector parallelogram. Right. So before moving on to the experiment, first let's recall the theory part of vector parallelogram. Right? Coming. You can come to the front if needed. Right? If you couldn't see the board, you can come to the front. Right. Can you pass it? Okay. So we are in the first experiment, first practical. Take down the heading as verification of vector parallelogram. Law of vector parallelogram. Verification of law of vector parallelogram. About breaks. About breaks. Yeah. During which time the Muslim students has to go to pray? Can anyone tell me the time? You know? 1:30. 1:30. Before 1:30. 12:30. You mean 12:30 to 1:30? I mean, right. 12:30 to 1:30. Right. Okay. Then the plan is this. Listen. Plan is this. Listen. What if now it's 9 almost? What if I continue straight up to 12:30 and give you a break from 12:30 to 1 and then continuing the rest? Or that's a one break of 30 minutes. Or I can give like 2 breaks of 15 or 20 minutes. What's better? I mean, for physical students, that would be fine. But for online students, sometimes when you are in front of a screen for like 3 hours, 3.5 hours, 4 hours, sometimes your focus will be like losing. That depends, not for all. Yeah, what's your preference? First plan is I can continue this straight up to 12:30 and we'll be giving a break of 30 minutes, right? We'll be giving a break of 30 minutes. Then you can come back to the class at 1, right? 30 minutes is enough to go and pray, right? So you can go pray and come. Is that only for boys? All right. Yeah, I should go for mosque. Then 30 minutes will be enough, right? Because we'll be finishing the session. I have planned to finish by 2:30, but if you do these things some kind of a, in a faster manner, like around 2 or something, let's try. We'll see. That depends on your speed. That's enough. Yeah, it's enough, no? Okay, we'll go with that plan. Right. Okay. Take down the heading. Verification of law of vector parallelogram. Right. So before the experiment, this is the theory part you need to know. See, this is a theory related to this. Now you have learned the theory of vector parallelogram in vectors, right? How many vector laws we have? How many vector laws we have in our syllabus? I'm just recalling you the stuff we have. Doesn't work for me. Doesn't work for me. You mean the Telegram link? Can you drop me a message to this number? WhatsApp, huh? Only WhatsApp. Yeah. How many vector laws we have? One? More than one? No idea. Three. So is this for the 27 batch too? Actually, the focus batch is 26, but that's fine. That's fine. For 27 batch also, vector parallelogram is done now. And now 27 batch, we are starting linear momentum today. Right? So that is fine. Because anyway, you need to learn these things one day. Right? And more earlier you can learn means more comfortable you are with that particular part when you go to the exam. Right? So therefore, that's fine. That's why I shared that in the 27 group as well. That is fine. That is fine. Since we are explaining from the scratch, so even though you don't know that particular theory part, you will get an idea after the explanation. 3. First one is vector triangle. Then vector additive law. Vector triangle law, vector additive law, vector parallelogram law. 3. Right? 3 laws. So it's okay. Right. The theory is this. Look at the board. If we can represent, look at the board. If we can represent any two vectors, let's say P and Q, if we can represent any two vectors P and Q using two adjacent sides of a parallelogram, right? Now, if these two are two adjacent sides of a parallelogram, to complete this parallelogram, we can draw another vector which is equal to this length here. That's a parallelogram. We know parallelogram is a equal and parallel side length. See, and here, say this is P. This is P. The diagonal which goes through these forces. See, the diagonal which goes through these forces. How many diagonals for a parallelogram? How many diagonals for a parallelogram? Oral maths. Only two. Only two. Right? One diagonal goes through these vectors. This is one diagonal which goes through vectors. Right? So this is given, this R is given by, or the other words, this diagonal is the resultant of these vectors. Vector addition. Vector addition is given by the diagonal. This is the theory. Right? And there's another diagonal, and that diagonal gives us the vector subtraction. Right? So that's a specialty in parallelogram. Using triangle, we can only get an addition. But using parallelogram, we can get both. Addition and subtraction using the same parallelogram. Now, verification is only for the addition. The reason is this. If it works for addition, subtraction is a negative addition. Definitely it works for a negative addition. Right? Now, in reality, in real maths, we don't have 4 mathematical functions as addition, subtraction, and multiplication and division. Only two. Only two mathematical functions. Addition and multiplication. Division division is the multiplication with fractions. Right? Division multiplication with fractions. So likewise, subtraction is the addition of negative numbers. Right? Subtraction lazy the same function. That's the same function. Right? Okay. So therefore, this is what we are going to prove. Now, if we can represent, listen again, if we can represent two vectors P and Q by using two adjacent sides of a parallelogram, right? The diagonal which goes through vectors gives us the resultant of vectors, right? That is the theory. Now, what we are going to prove here is, verify here is, whether this actually works out, right? Using some masses, known masses, we are going to find this out, and once it is verified, then we can use the same setup to find the mass of an unknown object as well, right? So we'll see how it's done. Okay. Did you get the root? Not yet? Okay, I'll check. Take down this work first as the theory. Take this down, then I'll explain. Under the heading, as the theory, explain this first. Take this down first, then I'll give you the theory. Take it down. Use different colors if needed. And I hope you have an idea that vector addition and numerical addition are two different things, huh? Right? This notation is for vectors. These two are different, huh? 3 plus 4 and vector 3 plus vector 4. These two are different. What is 3 plus 4? Yes, come. You also couldn't find the place? You couldn't find the place? Okay, that's fine. We have just started. Take down the heading and take this down. 3 plus 4. What's the answer? 7. Vector 3 plus vector 4? It's actually 5. This is like this kind of a scenario. 3 newtons, 4 newtons. The resultant is 5 newtons. Right? So vector addition and the numerical addition are two different things. Math students know this. You have done vector addition? Right. So that's why this notation is put to say that it's a vector. And if you are representing a vector using two letters, we will be using another different notation. What is that? If we need to represent a vector as this using two letters, we are using this notation, right? To represent a vector using a single letter, this notation is used, right? So we have discussed these things. I'm just recording. Okay. Finished. Okay, below this, write down the theory. Use a red pen and write this down. 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 If any two vectors can be represented using two adjacent sides of a parallelogram. 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 The diagonal which goes through vectors. The diagonal which goes through vectors. The diagonal which goes through vectors. The diagonal which goes through vectors represents resultant vector. Represents resultant vector. goes through vectors represents resultant vector. The diagonal which goes through vectors represents resultant vector. Right. Yeah. So please be active in the class. The reason is now like this I'll be discussing everything from scratch. Right now, otherwise now in the tute I haven't put this tute මම කියවන tute එකේ තියෙන්නේ නිකන් summary එකක් විතරයි. And that's the exact details that you can find if you download the resource book from NI. Right? ඒකේ තියෙන summary එකක් විතරයි. But just by going through that, sometimes you won't get the whole picture. Right? So that's why we need to explain, we need to discuss these things in a comprehensive and in-depth manner. Right? Now, even though this is a holiday, now you are here because of you have this dedication, you have this need of learning this. So therefore, please be in the class, please be active in the class. Always when I ask something, doesn't matter whether you are on Zoom or YouTube, I can see both chats. You can engage answering, right? Because I need to engage you with answering, because then I can get an idea whether you are actually here or have you understood or not. You are on the track simply, right? Okay. So what's that? Oh, yeah, that's the intersection point. Point O. Right. Look at the board. Look at the board. Don't write anything. Just look at the board. In our school labs, this setup is available. Right? This is a setup. Setup in the sense is called the setup of or the apparatus of vector parallelogram or setup of vector parallelogram. Right? This is a board. To this board, two pulleys are fixed. Right? ඒක already තියෙන setup එකක්. Strings දාලා නැහැ, mass set කරලා නැහැ. මේ setup එක තියෙනවා. හරිනේ? School lab එකේ මේ setup එක තියෙනවා. අර නැත්නම් ඉතින් අපි මේක මේ class එකේදී නිකන් හදාගන්න බෑ. I mean, it's possible but it takes time. මේක frictionless විදිහට හදන්න ඕනේ. ඒක lazy නෑ. Right? මේක setup එකක් තියෙනවා. These are already having set up in any laboratories. Right? මේ තියෙන board එක. This is a wooden board. Onto that wooden board, two pulleys are fixed. Right? And what we need to do is we have to have two strings. Right? Listen. We have to have two strings, and I'm going to connect these strings like this. I'm going to connect these strings like this. And if I draw the exact thing that you see in school, and for this string we have to connect a pan. You know what a pan is, right? Like a balancer. Balance එකේ තියෙන pan එක. Not pan balancers, අර normal balance එකේ තියෙන pan එක. Like this to put something in, right? So such kind of pans are there. Small pan එක මෙන්න මේ වගේ. Very small pan, right? අන්නේ pans මේකට connect කරනවා. So it's actually like this when the pans are connected. Right? Okay, now how many strings are here? No, only two. Only two. This is a single string and this is another string. Only two strings. Right? Now, if I have hung something using a middle point of a string, it comes down. So that is what has happened here. That's the same string. This is the same string. This is the second string. Right? Only two strings. Only two strings. Okay. Now, we have to have three known weights first. Three known masses or three known weights. Right? Three known weights. This is important. Three known weights. Three known weights. Three known weights. Right? මුලින්ම unknown weights අරගෙන මුකුත් කරන්න බෑ. If this is verified only, As the next step, we can find the unknown weight. Give me a second. I haven't disabled the whiteboard sharing. Someone is using the whiteboard. Okay, now I have disabled. Okay. Right. If you have any questions, you can put to the chat. Otherwise, now, if you are putting like unknown things, I'll block you from the chat. Then you can't put any messages until the meeting is ended. Right? So it's up to you to decide. Right? There are options. There are options, and now if needed, I can block you from my Zoom account. And if I block you from the Zoom account, you can't join into this Zoom account meetings again until I unblock you. So likewise, teachers are there. Just put the academic stuff, or if you have any questions, to the chat box. Reactions are fine, right? And if someone has asked a question, if anyone of you know the answer, that is totally fine. You can answer, because now I'm always saying in classes, this is not a individual thing, right? You have to go through the exam as a group. That is better, right? Otherwise, individual competition is not always good, right? Now, when it comes to universities, that environment is not there. In universities, always like we are trying to go through as a batch. That attitude is, it's like a nice attitude, right? Because the thing is, now if there are like repeat students in the batch, right? Let's say now from the batch, 10% of 10% or this kind of percentage is repeat of students are repeated. Then there are some cases where then whole batch is not getting the chance to go for the convocations, right? So therefore, always learning as a team, learning as a group is encouraged there. And that's a very good approach. Unlike A levels, you will see that difference. That's a huge difference when you go to universities, right? In state universities, that is at the top level, and in private universities also, that is they are up to a certain level, right? In state universities, that is at the top level, right? සමහරලාට ලෙක්චර් එක තේරෙන්නේ බැච් එකේ එක ළමයෙක්ට විතරයි. ඒ ළමයා ඊට පස්සේ බැච් එකටම කියලා දෙනවා. ඒ වගේ කේසස් හොඳනම් තියෙනවා. එහෙම තමයි ගොඩ යන්නේ. Right? So therefore, learning as a group is highly encouraged. So therefore, now if I didn't see your question in the chat, and if any one of you know the answer, feel free to send the answer if you are confident enough about the answer. That is totally fine. And I don't mind whether it's correct or wrong. If I saw it whether it's wrong, then I'll correct it. No, otherwise, you can share it among yourselves, because now all of you are here to achieve a same goal, right? මෙතන A levels කරන්න විතරනේ කොහොමද තින්නේ? A levels කියන්නේ A level physics කරන්න විතරනේ. Right? That is fine, okay. What I was explaining was, now first we have to have three known weights, right? Three known weights. So let's say the weights are W1, W2 and W3. This is W1, right? Or else you can write this as M1G. So straight away I am taking the weight as W, right? W1, W2 and W3. Three known weights, right? Now, if this system is in equilibrium, right? If this system is in equilibrium, if I think of this point here, look at the board. Let's say point O again. If I think of this point again, if the system is in equilibrium, this point is also in equilibrium, no? Right? And there's another theory you need to know. If any object is in equilibrium under three non-parallel forces. If any object is under equilibrium, in equilibrium under three non-parallel forces, all three forces intersect at the same point. And there we discussed five features, right? We have five features. If you have these kind of forces, we discussed in equilibrium. Resultant of any two reactions or resultant of any two forces should be same in the magnitude, equal in the magnitude to the third force and opposite in direction. It makes sense, no? Because now if this is in equilibrium, total resultant has to be 0, right? If this is in equilibrium, total resultant has to be 0. So therefore, let's say the resultant of these two is R, right? Then if I can narrow down the resultant of these two as R, then only two forces remains. If a system is in equilibrium under two forces has to be parallel and opposite, right? It should be parallel and opposite. And acting at the same point. Otherwise, if the point is different, it creates a force moment, right? So therefore, R and this remaining force has to be equal. This works for any two forces. So therefore, if any object is in equilibrium under three non-parallel forces, resultant of any two forces is equal to the third force and opposite in direction, right? Now, let's mark the forces acting here. Okay, tell me, how many tensions are here? How many tensions in this system? How many tensions? How many different tensions in the system? How many different tensions in the system? Now, for this experiment, listen. For this experiment, we are considering light strings. Light strings in the sense, puluwan tarang thin strings samai ganne. Ropes wage ewa ganna bෑ. Then it won't be light, ne? So therefore, we are using light strings, very thin strings, such that we can neglect the mass of the string. So they are light strings, right? You can always assume them as light strings, right? And these pulleys are also frictionless. We have a method to check it out whether it's having friction or it's frictionless, right? I'll explain it later after explaining the theory part. Yeah, how many different tensions? Tell me. 3. One says 3. Others? I heard something. 4. 5. How many different tensions? I'm not asking about terminal tensions or something. How many different tensions here? How many different tensions? 2. What do you say? 3. Same. 4. 3. It's actually 2. Yeah, it's 2. It's actually 2. Because tension changes if the string changes only. For a given string, tension remains same. For a given light string, tension remains same. Right? Tension changes if and only if the string changes. Or it should have intermediate obstacles like this. Straight string ega the same tension ega. See, now if I mark these tensions, it will be like this. Let's say this is T1, right? Up to here there is T1. Up to here there is T1. And that side also there is T1. Then up to this point there is T1. Right? And after this point it changes. Let's say T2, T2, T2 and T2. Now on this string, we have two different tensions. On this string, we have two different tensions, right? And if I mark the tension on the other string also, right? Now, first I asked about this one, only two different tensions. And then about the second string, there is another one different tension. So altogether, it will be three tensions. T3, let's say, T3, right? So altogether, it's three different tensions. Understood? Now, these three different tensions are, see, it is like this. Now, this point is in equilibrium under three non-parallel forces. Then, simply, the resultant of T1 and T2 should be equal and opposite to T3. Right? Otherwise, it won't be in an equilibrium. Okay. That is what we are going to see now. Okay, first I need you to take this down. So before taking down, let's mention about the apparatus and the instruments we are going to use. Right? Then I'll explain the method. Method I didn't explain the method yet. This is just the setup. Then setup කරගෙන තියෙන්නේ. setup එක කරගෙන තියෙන තාම experiment එක කරේ නැහැ. මෙතන setup එක. ඒතර lab එකේ මම කරන්නේ board එක විතරයි තියෙන්නේ. masses වෙනම තියෙනවා. You have to get these masses and you have to tie them with these strings and make this setup. Right? Strings දෙකක් ගත්තා. masses ටික ගැට ගහගත්තා. setup එක හදාගත්තා. Right? නැත්නම් මේක already setup කරලා නැහැ. Rarely in some schools මේක නිකන් wall එකක වගේ fix කරලා තියෙන්න පුළුවන්. අන්න එහෙම නැත්නම් setup කරලා තියෙනවා. සමහරලාට එහෙම තියෙනවා. Right? I have seen in some schools. Now, since this is only used for vector parallelogram, this setup is fixed to a wall. Then anyone can use it at any time. That is fixed to the wall, and in that case, these strings are already there, also there. If that is fixed, otherwise, if this is inside a cupboard or something, this is not set up. Then we have to take it out from the cupboard and you have to do this setup, right? Okay. Okay, then as the next thing, first write down materials and apparatus. Heading. Materials and apparatus. Materials and apparatus. Next heading. Materials and apparatus. Materials and apparatus. Okay. First, I'll mention all materials that we need for the experiment. And I haven't explained about some of the materials yet because this is just the setup I explained. Right? So first mention these materials one by one. First materials, one by one. First one, 3 known weights. First one, 3 known weights. So why have we tied the W2 mass with both strings? No, that is to create 3 non-parallel forces, because we have to have 3 forces like this to verify vector parallelogram, to verify the law. So that's why we are creating it. දෙකක් විතර තිබ්බොත් verify කරන්න බෑනේ parallelogram එකකට දාන්න. Right? So we have to create it. That's why this setup is used. Yeah. Right? First one, 3 known weights. Second one, apparatus of vector parallelogram. Apparatus means this entire thing is called the apparatus. Apparatus of vector parallelogram. Next. Now this comes with not the verification. Now I told you before that after the verification we can find a weight or the mass of an unknown weight, unknown mass. Right? For that also we have to have a small stone or a glass stopper. Glass stopper කියන්නේ මොකද? Stones, දන්නවනේ. You know stones. Stone එකක් ගන්න පුළුවන්. Glass stopper. What are glass stoppers? Glass stoppers කියලා කියන්නේ අර සමහර bottles වල එන්නේ මේ උඩ lid එකක් glass වලින්. ඒක glass stopper එක කියලා කියන්නේ. අර මෙහෙම ගහන lid එකක් කියන්නේ not to like rotate and release. අර glass වලින් එන lid එකක් තියෙන. අර අනිත් එක නෙමෙයි. That is called glass stopper. Right? Glass වලින් එන lid එකක් තියෙනවා. Right? ඒක lab එකේ තියෙන ඒක ඒ කියන්නේ glass lid මේ glass stopper එක ගන්න බෝතලයක් ගන්න ඕනේ නැහැ. ඒක වෙනම ගන්න පුළුවන්. Right? Apparatus of vector parallelogram. Then small stone or glass stopper. Glass stopper again, glass lid එකක්. Glass stopper. Right? Then a set square. මේ දෙක එකක් තිබ්බනම් ඇති. A set square, you know what the set square is, right? A set square or a small mirror strip. Small mirror strip. a set square or small mirror strip. Then half meter ruler. Half meter ruler. Half meter ruler. Then a white sheet. A white sheet. A white sheet. White sheet can white paper. A white paper. A white sheet. Right? Then pins. Pins. And last, we have to have a balance. So we can use either a triple beam balance or an electronic balance. Right? Last one, triple beam balance or electronic balance. 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 Right. Okay, now again take down a subheading as apparatus. Again take down a subheading as apparatus. Apparatus. Subheading as apparatus. Take down a subheading as apparatus. Take down a subheading as apparatus. And now take this down in a clear manner. Take this down in a clear manner. It should be very clear to you. So you can use different colors. That brown wooden thing. No. Not the wooden one. Not the wooden one. Glass වලින් එකක් එනවා. මම ෆොටෝ එකක් ඕනනම් පෙන්නන්න. මේ ඒක ලැබ් එකේ තියෙන්නේ wooden එක මේ يعني it's too light. එතකොට අපිට ඕනේ weight එක එන්නේ නැහැ. wooden එක use කරන්න බෑ. Right? No, I don't think it's visible. මේ තමයි glass top එක කියලා කියන්නේ. Right? අර wooden එකම තමයි ඒකම glass එකක් තියෙනවා. Right? Wooden one is too light. ඒ වගේක් මෙතන use කරාට මේක මේ පාත් වෙන්නේ නැහැ. එතකොට අපිට හරියට experiment එක කරන්න බෑ. It's too light. Glass toppers are available in lab. කියන්නේ අපි bottle එකක් අරගෙන glass topper එකක් හොයාගෙන යන්න ඕනේ. It's available in the lab. It's already available in the lab. Finish? Keep this note with you. Keep this note secured with you until your exam, because today I'll be discussing everything you need to know. Right? You won't get any question beyond what we are discussing today. Right? So therefore, prefer this as a final note, a complete note for any question until your exam. Right? If you are using sheets, attach them to the tute later and keep it secured. And for online students, if you need to get a hard copy, you can get that PDF and get it done from any print shop, right? Okay, finished. Right. Listen. Now I'm going to explain the method. Listen, this is the most important part in an experiment. Method. Method means this is the core of the experiment. Method එක තමයි ඕන experiment එක දැනගන්න ඕන part එක. I mean, the part you need to realize, you need to understand in any experiment is the method. Right? Knowing theory is just a fact. Knowing theory doesn't mean that you know the experiment. We have to know the method. then only we can connect that theory with the method, right? That is what we do in an experiment. මොකක් හරි තියෙන theory එකක් prove කරන්න experiment එකක් තියෙන්නේ. නැතු අපි අලුත් theory එකක් හොයාගන්න experiment කරන්නේ නැහැ. Right? We are going to prove, verify a theory that is already existing, right? So therefore you have to know the theory. That's why we discussed about the parallelogram. That's a connection here. And now we are going to use a setup, some kind of apparatus, and going to check whether it's correct. So therefore knowing theory is it's a basic, it's a fundamental thing, right? So knowing method means, understanding method means, then you will see the logic behind the method and the links with the theory of this method we are using. Then only we can come to the conclusion later, right? The ultimate result of any experiment is a conclusion, right? Then at the conclusion we should be able to see whether it's verified or not, right? It should be verified. That's the idea. Okay, first thing is this. Now we have a white sheet. No, we have a white sheet. A white sheet. Usually A3 size. Okay, it's like A3. It should be. This is usually larger than A4 size. So therefore, the sheet should be like A3 or A2 or something like that, right? First, we have to take that sheet, and before this strings are put onto this, before these strings are put onto this, we have to fix that sheet here onto this board, using pins. We have pins, huh? Yeah, pins. We have pins, right? So using 4 pins. Have you heard about drawing pins? Drawing pins kill put pin there. So usually we are using drawing pins. And on this board, to make it easier, this part is made of regiform. Okay. This is actually a wooden board. In front of the wooden board, a regiform board is also fixed to make it easier to fix pins, right? So therefore this is a regiform part. මේ part එකේ කොහොමද තව regiform එකක් තියෙනවා. නැත්නම් අර දැන් wood එකට මේක ගන්න ගියාම අමාරුයිනේ, right? So therefore that's there in the setup. It's already there in the setup. So take that sheet. This is a white sheet. And we are fixing that white sheet onto this using these pins. 4 pins. Like this. Right? And then you have to complete this setup. Now what we have is the white sheet at the back. Right? White sheet at the back. And in front of the white sheet, 2 pulleys. And this setup is hanging. Right? And before starting the experiment, we have to check whether these pulleys are actually frictionless or not. Right? It should be frictionless. I mean, it's supposed to be frictionless to get an accurate result. So therefore, now before doing the experiment, we will check it. Otherwise, if there is having friction, if there is not frictionless, our results may be inaccurate, not accurate. Right? So therefore, for that, what is done is this. Now, after the setup is done, this middle mass at the center, this mass is dragged down and released. This is dragged down and released, right? So once it is dragged down and released, if it is coming to the same point it was before, to the initial point. Now initially, say it's here. Now we are dragging it down like this and then released. Again, if it's coming back to this point when resting, which means there is no friction. Right? Same energy. මෙතන තියෙන energy එකම මම drag කරලා ආයි තිබ්බත් තියෙන්න ඕනේ. According to law of conservation of energy. That's a logic. Right? So therefore, that is what we do. මැද එකෙන් විතරයි අදින්නේ. එහෙන් අද්දොත් එහෙම setup එක imbalance වෙනවා. Right? අර එහෙම කැමති එකෙන් කරන්න බෑ. Drag this down and release. And check whether it is coming back to the same initial point or not. If it is coming back, there is no friction. If it is not, there is friction. If there is friction, you have to apply lubricants to these 2 pulleys to make it frictionless. Right? So ඒක decide කරන්න ඕනේ before doing the experiment. Experiment එක කළා මේක check කරලා වැඩක් නැහැ. එතකොට ඉතින් result එක ඇවිල්ලා නැහැ. Right? So therefore, as a precaution, we do it. Right? So if not, we can use lubricants here, lubricant oils here, and minimize friction. Right? Now, let's say it is coming back to this point. Everything is working fine now. Right? Okay. Now, these three are three known weights. No? These three are three known weights. So, therefore, let's say this weight is W1. Then what's the value of T1? Anyone? What is T1 in terms of these weights? What is T1 in terms of these weights? Engage answering. Is this system in equilibrium? Yes. This is a system in equilibrium. Right? If there is a system in equilibrium, we know two conditions are satisfied. Right? One is resultant force along any direction will be 0. Or resultant force moment about any point of the system will also be 0. Right? Now here there are no moments, but you can check forces. What is C1 in terms of weight? Very simple. T1 equals W1. T1 equals W1, vertical equilibrium. This is in an equilibrium. If the system is in equilibrium, the entire system is in equilibrium. Right? Point at equilibrium again. If the system is in equilibrium, all the points in the system are in equilibrium. So this weight is also in an equilibrium. T1 equals W1. Right? And T2 equals W3. Right? But we don't know about W2 equals T, let me mark the other way, that will be easy. I'll mark this as T3, yeah? T3, 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 then T3 and W3, and this is 2 kilogram. Method notations pattern. Right? That's fine. Right? T1, T2, T3. And T2 equals W2 and T3 equals W3. But still, we don't know the relationship between T1, T2 and T3. Right? But for sure, we know that the resultant of T1 and T3 has to be T2 in terms of the value, and it should be opposite in the direction since this is in equilibrium. Equilibrium, we can see it by our own eyes. If there is not an equilibrium, it should be accelerated. So the system is not accelerated. System is at rest. So that is an equilibrium. Right? So therefore, now we know there is a relationship between T1, T2 and T3. And actually T1 is W1, T3 is W3, and T2 is W2. Which means tensions are known. Because these three are three known weights. These three are three known weights. Right? And when we select these three weights also, we have to have three weights which are like approximately equal. ඒ කියන්නේ ලොකු ඩීවියේෂන් එකක් තිබ්බොත් එහෙම මේක බැලන්ස් කරලා තියන්න බෑ. හිතන්නකො මේ පැත්තට 10 කිලෝස් විතර දැම්මා කියලා මේ සිස්ටම් එක කඩාගෙන වැටෙනවා. 10 කිලෝස් බැලන්ස් කරන්න බෑනේ මේ පැත්තේ ඉන්න නිකන් පොඩි weight එකකින්. Right? පොඩි weights ආන්න ඕනේ. ඒ කියන්නේ like 230, 250, 270. Approximately equal. Equal ඒවා නෙමෙයි, approximately equal ඒවා. Right? ලොකු deviation එකක් තිබ්බොත් බෑ. If there is a deviation like if you are using 100 grams with 1 kilogram, that's not going to work. මේ system එකේ තොර මේ පැත්ත පාත් වෙනවා. Right? Okay. Now come back to here. Now we know the acting line of T1 is along the string. Listen. Acting line of T1 is along the string. Acting line of T3 is along this string part. And acting line of T2 is along this string part. Right? Now, acting line is known means the angle between forces and acting lines of forces are known. Now, to draw a parallelogram, now beforehand we have to know this. Then only we can draw the parallelogram. Which means acting line should be known with the angle. Acting line should be known with the angle. Now, I'm going to find out, and we are going to find out the acting lines of these forces like this. For sure, we know that is on the string, right? So, which means we have to get the exact directions of these strings onto this paper somehow, right? For that, there are two methods. Listen, for that there are two methods. And when a question is coming, you will be questioned about these methods, right? That is how usually an experiment, a structured essay question comes. 1 second. When you send messages to the Zoom, if you are sending direct messages, direct them to the Meshma account, right? Not my personal one. Yeah, that's the visible account on the screen. That's why, right? Okay. Now, to take this to this paper, there are two methods. We have a set square and a small mirror strip. And a set square or a mirror strip. Right? Say one string is like this. If the string is like this, now behind this we have that white sheet. Right? You know set square, right? Set square. Right? Method 1 is this. There are two methods. I'll explain both. Listen. Method 1 is this. Method 1 is using set square. Right? Using set square, what we can do is we can keep this set square as it is perpendicular to the board like this. Right? We are placing the set square as it is perpendicular to the board like this. As it is perpendicular to the board like this. And we can take it closer until it just touches the string. Just touches the string. Right? And then now using this, if I draw a line here using a pencil. Using a pencil. Now using a pencil, we can draw the edge here, the line here, which goes along this set square. Set square anyone has got a set square? No. You can imagine, right? මේ set square එක මෙහෙම තියන්න ඕනේ මෙතනින් ගිහිල්ලා. මෙහෙම අරගෙන මෙහෙම තියනවා. මොකෙන්ද වෙන්නේ? The set square is like this. So this side of the set square should be kept on the block like this. Kept on the board like this. Right? And this is an aerial view here. Right? And we are taking it much closer to the string as it just touches the string. Right? And then using a pencil from the other side, make a contact. Now if your set square is in contact with the string, it's going to change these tensions because some part of the tension is coming to the set square. Right? So it should be kept as it just touches, in the sense actually it is not touching. Right? Not touching. Just touches. Right? And from the other side, you can use a pencil and draw that line. Can you imagine? මේ පැත්තෙන් pencil එක ගන්නවා අරගෙන දැන් මේකව මෙහෙම තියලා තියෙනවනේ. මෙහෙම තියනවා. As it just touches the string. Take a pencil and from the other side, then මෙතන පොඩි space එකක් තියෙනවා. There's a small space between the sheet and the string because this thickness of the pulleys are here නේ. පොඩි space එකක් තියෙනවා. මේ space එකේ මෙහෙම කරලා මේක අඳිනවා. Right? Then you can mark, let's say this is the white sheet. Let me do it here. See? Now let's say this is the white sheet we have. That white sheet. Say this is the white sheet we have. Now on the white sheet, then this direction can be marked like this. Right? And same thing is done for this one as well. Right? Same thing is done for this one as well. And that direction can be marked. Right? That can also be marked. And then about method 2. This is method 1. No? This is method 1 using set square. And method 2 is using mirror strip. Using mirror strip. Using mirror strip, that is more accurate. Listen. So therefore, it's a must to you to know about the mirror strip case. That's the accurate case. Right? So using mirror strip, this is what is done. Questions? Okay. Using mirror strip, this is what is done. We are keeping the mirror strip. Behind the string like this. Right? Behind the string. Right? We are keeping the mirror strip behind this. And when you see through the mirror, we will see the image, the reflected image. That's a plain mirror. It is then moon mirror එකක් අර තියෙන්නේ. මොනවාද dressing tables වල තියෙන ඒ වගේ පොඩි mirror එකක් පොඩි strip එකක් මේ වගේ. චූටි strip එක. Mirror strip. Right? Now from this mirror, we can see the reflection of this. So when you check from either sides, you will see the reflection. Right? And there is one point at where the reflection is exactly covered by the actual string. The reflection is exactly covered with the actual string. මෙහෙම දෙකම පේනවනේ. මේ ඔයා මෙහෙම බලද්දී ඔයාට එක තැනක් එනවා හරියට මේ cover වෙනවා. Reflection එකක් නේ තියෙන්නේ. Right? Shadow එක වගේ තමයි. Reflection එකක් තියෙන්නේ. That reflection will be covered at any point. ඒ කියන්නේ ඔයාගේ angle එක වෙනස් කරලා ඔයා බලන්න ඕනේ. You have to change the angle that you are looking at. And then at one point you will see there's a point comes as the reflection of mirror strip or the image of string on the mirror strip is covered by the actual string, right? Which means both are coincided at that position. So there what we do is at that position we will mark these 2 points like this. Again, by taking a pencil, we are marking these 2 points, right? The mirror strip එක perpendicular තියෙන්න ඕනේ. If your mirror strip is not perpendicular also, you won't see it. So you have to rotate the mirror strip as it is perpendicular. And then when you look from the top, you will see the image is exactly covered with the actual string itself, right? At that position, mark the mirror strip, mark the positions of mirror strip close to the string like this. And then we can take this out and connect these 2 dots. Once the dots are connected, that's the direction of acting line of T1, right? And we can do the same, you can perform the same for T3. And again, you can perform the same for T2, right? And for T2, once you did it, you will get something like this. Then direction you will get something like this for T3, right? Now, these are the 3 directions. These are the 3 directions that we have taken to the white sheet now, right? And when we do so, white sheet should be firmly fixed onto this. It should be firmly fixed. And once these 3 directions are marked on the white sheet, we can take this out onto a table. Right? We can take this out onto a table. Right? Now this is the white sheet we have with the directions of forces. Right? Okay. There are a few more things to explain. So before that, we'll write the note and then come back. Right? Otherwise, if I explain everything at once, so why are we making in pencil? That is fine. Using a pencil because now if there's something goes wrong, you can erase. Simple as that. Right. Okay, then as the next heading, write down method. Next heading, method. And when you write down method, write it as 1 by 1, like 1, 2, 3, 4 number wise, because this method is in an order. Right? I'm giving this method in an order. That's the same order you have to follow. Right? First point, first one. Fixed white sheet. Fixed white sheet. Fixed white sheet. Fixed white sheet. Onto the board using pins. Onto the board using pins. Fixed white sheet onto the board using pins. Fixed white sheet onto the board using pins. And number two, keep known weights W1, W2 and W3. Keep known weights W1, W2 and W3 on pans, PAN, pans, on pans. Next point. By using set square, or by using mirror strip, Mark projections. Projection means shadow. Projection means shadow. Mark projections of strings on white sheet. Mark projections of strings on white sheet. Within brackets. Consider the occasion when image of string is covered exactly with actual string. Is covered or slash say coincides. This is the exact word actually. You know what coinciding is, huh? Or Vernier scale salam again. Covers slash coincided with actual string. Coincided with actual string. Right? Next point. Remove white sheet from board. Remove white sheet from board. Remove white sheet from board. And connect mark dots. To extend actin lines. And connect mark dots to extend actin lines of forces. Right? Next point. Measure weights of pans. And add it to non weights. Measure weights of pans and add it to non weights. Right? Listen. Now, without using pans, if you just tie this to the string, right? That is also a possible method to do, right? If you just tie the glass stopper to the string, no weight of the pan is coming. In that case, W1 and T1 are exactly equal. But if we are using pans, usually pans will be used, right? If we are using pans, pan is also having a weight, something. It's very light, but still it is non-zero. No? It is light, it's too light, but it's non-zero. So therefore, since we need to increase the accuracy of the experiment, right? We can weigh one of these pans using the beam balance, right? Triple beam balance. Pan ekak measure karna. And if the weight of the pan is known, now actually what happens is T1 is counterbalances to W1 plus weight of the pan. So that's what I said as add that weight of the pan to known weights. That's the idea, right? That is an approach, that is a precaution we do to acquire a higher accuracy, right? Okay, next point. Before writing next point, listen. Now we have these directions. No, listen. Now we have these directions marked here. We have these directions marked here. Now, if we are drawing the parallelogram should be drawn with a scale, right? It should be drawn with a scale. So therefore, we can come up with our own scale as this space of the sheet is manageable, as it is manageable with the space of the sheet, right? Now, as an example scale, something like this. Let's say 10 grams, 10 grams, 10 grams by 1 centimeter. This is a scale. 10 grams by 1 centimeter. Now, T1, T2 and T3 are known forces, no? Because T1 equals, now if I connect it to the pan, then T1 equals weight of W1 plus weight of pan, and T2 equals W2 plus weight of pan, T3 equals W3 plus weight of pan. Simply, T1, T2 and T3 are known weights. Now let's say T1 is 10 newtons, right? Let's say T1 is newtons, that is fine, huh? Totally fine. Let's say something like this. 1 Newton is by 1 centimeter. Now, if you know these values in newtons, you can go with newtons. If you know the values in grams, you can use grams. That is fine, because even though the G changes, the ratio remains same, right? Okay, now, which means T1, T2 and T3 are known. And now, when we plot this respective vector, now we have to adhere to that ratio, that scale that we are following here, right? Now, let's say T1 is 5 newtons, then you have to draw a line of exactly 5 centimeters in length. Got it? That's the idea of the scale, right? That's the idea of the scale. Now, let's assume we have this kind of a scale. Now, according to that scale, we have to extend these lines according to the scale. So, according to the scale, you can extend these lines like this. Let me draw this again, then you will be taking this down onto your note. Now, we have this on the sheet like this, and these are extended according to the scale, right? This is a scale that we can decide based on the space you have, right? So if you have a A3 sheet, now we don't use a scale as it is like narrowing to one end of the sheet, right? We have to have a good spread. When there's a good spread, always random errors, percentage errors will be less. So therefore, we are going to use, so therefore, we are going to have a good scale as it is spread around all over the sheet. That's the whole idea, right? I use 1 Newton, 2 centimeters, 3 centimeters, that doesn't matter as long as it spreads on the sheet, right? That's a scale we can decide. And according to that scale, now we have to extend these two. Look at the board. According to that scale, we have to extend these two, right? And if these two are extended, now what we can do is you can complete the parallelogram. You can complete the parallelogram like this. You can complete the parallelogram like this. O is here, right? Now having this part is not mandatory, right? O is here. And let's say O, A, B, right? Now this is OA, this is OB, right? OA and OB. And actually these two represents forces T1 and T3. Now this represents T1, this represents T3, right? And now the parallelogram is drawn, which means these sides are equal and parallel, right? Now vector parallelogram is constructed. Listen, now this is the most important part. Now the vector parallelogram is constructed, right? If the vector parallelogram is constructed, we can find the result or no? We can find the result. Now this vector parallelogram is in the scale, according to the scale, which means now in this parallelogram, let's say this is 10 centimeters long, which means I'm representing 10 newtons there. If this is 8 centimeters long, I'm representing 8 newtons there. That's the meaning. That's the meaning, right? And then after doing all these things, we can connect this diagonal. You can connect the diagonal. And if the theory is correct, the diagonal should give us the resultant. If the theory is correct, the diagonal should give us a resultant, and that resultant should be equivalent to T2 since this is in equilibrium, right? So what we do is, now we have a half meter ruler. We have a half meter ruler, right? Take that ruler and keep it here and measure this, right? Now let's say this was 13 centimeters long. Now once we measure this, I got it as 13 centimeters long. Convert it to the other side, which means that is 13 newtons, right? Now we know this weight because we have already measured that weight using triple beam balance. Now if that coincides with that measured value, which means vector parallelogram is verified. Already measured. Now we have measured W1, W2 and W3. They are known weights, and we have measured these spans. Now addition of W2 plus span is, let's say, 13. It has to be 13. And once you measure this also according to the scale, it is coming to 13. Definitely it is 13, right? And with that, we can verify whether the vector parallelogram is correct or wrong, right? That's the purpose. Then we have known weight එක. අපි බලන්නේ parallelogram එකනොත් ඒ weight එක අපිට දෙනවද කියලා, right? So if vector parallelogram is correct, what it gives is the resultant of these two. But from the equilibrium we know that resultant has to be equal to T2, right? So from vector parallelogram, from the scale, we can convert that back to the weight here, and practically you can measure these two from the balance and you can compare these two. If these two readings are equal, vector parallelogram is correct, right? There is the experiment. Right? Any questions? Now from here the experiment is over. Now other than that, there are some like remarks or special points to be mentioned. I'll mention all these points later. Like what's the reason we are doing all of these markings, keeping the set square or mirror strip? Set square or mirror strip. Now without using a set square or mirror strip, just by observing a thin string by a naked eye, we can't find the correct direction. Let's assume this as the string, right? When we try to mark the image of the string, someone may mark here, someone may mark here, someone may mark there. Right? It is not going to work. That's the thing. String string pencil string right? That's why a set square or a strip should be used. Mirror strip is the most accurate method, right? Clear? Any other questions? So why we consider pan weights? Because the equilibrium is actually with the pan weights. If pans are not light, let's say this pan weight is M1G. So actually T1 equals M1G plus W1. Vertical equilibrium. Right? That's why. Now if you hang it using the string itself, no need to consider pans. Right. Any other questions? All good? The ones on YouTube? Oh. So your audio keeps getting cut off at certain bits. Why is it? Is it same for the ones on Zoom as well? Let me check. Is it same for the ones on Zoom as well? The 6 pins. We have pins, huh? Yeah, we have pins. Right? So using 4 pins. No, it's working fine. I think it's something about your connection. I guess I'm not sure. But if you're on YouTube, that's rendering is like manageable compared to Zoom. It's working fine, no? Students on Zoom, is that same for you? I mean, do you also experience cutoffs of voice, or is it solid and firm? Clear? Mostly I think it's something with your connection. I guess it's something with your connection. Now I check with mine. It's working fine. All good. Okay. Mostly connection එක හරියන්නේ නැහැ හැමදාම classes වලදී මේවා වෙනවානේ. Starlink ගන්න. Or let's change the network simply. Starlink. No, I'm just kidding. Change the network. Change the network if it's low on coverage. So can you explain the mirror thing again? Yeah. Listen. Now, if we keep the mirror strip, let's assume this as the mirror strip. This one. Now, if you keep the mirror strip behind the string, right, like this. Now, when the mirror string is rotated, and when you look at the string, look at the image from the top, you will see the image of mirror, the string on the mirror string, right? Now, if the image and the actual string is coincided like this, coincided means you don't see the image when you look at it from the top, right? Which means they are coincided. Image which means image is coincided, right? At that scenario, the idea is this mirror strip is exactly perpendicular to the string. It is perpendicular to the string, right? So therefore, if you mark these 2 points on the string close to string, on the board close to string, that gives us the direction of the string there, right? Correct? ඒක mark කරලා මේක අයින් කරනවා. අයින් කරාම dots දෙකක් තමයි තියෙන්නේ. So what you have on the sheet is 2 dots, and then take it out and connect dots. Right? මේක තියාගෙන connect කරන්න යන්න බෑ. මෙතන දැන් string එක කරදරයිනේ. මෙතන dots එක තියාගත්තා. මෙතනින් 2යි. මේ පැත්තෙන් 2යි. Minimum 2, and when we keep dots, if we can keep dots with a kind of a significantly higher space, the accuracy is higher. What's the reason? Now, when we have 2 dots like this, look at here. Let's say you are going to connect 2 dots like this, right? Now, when you are connecting these 2, now these kind of deviations can happen. Now, even though if you are connecting using a ruler, these kind of deviations can happen. But if these dots are a little bit far, see, the deviation is minimum compared to this. Then මේ දෙක මේවා කරද්දි මේකට deviation එකක් එන්නේ. තේරුණාද? මේ dots එකක් ළඟ තියෙද්දි අපි මෙහෙම connect කරද්දි මේ බලන්න එන deviations වැඩි, angles වැඩි. dot එකේ ගෑවිලා ගියත් මේ line එක. හැබැයි dots එකක් ගොඩක් ඈතයි නම් තියෙන්නේ. මේ මෙයාව deviate වුණොත් පොඩ්ඩයි deviate වෙන්නේ. මේ තරම් angle එක deviate වෙන්නේ නැහැ. Right? So therefore, keeping dots at a significantly higher space as possible is better. Everything is good. Clear. So will this class upload in YouTube? Yeah, that's live streaming. So can you again show how you draw that parallelogram inside the red box? Inside the red box, this one. Now, after connecting these lines, listen again. Listen. After connecting these dots, we have extended that according to the scale we are using, right? According to the scale. Now, let's say your weights are 10 newtons and 12 newtons. For 10 newtons, 10 centimeters. 12 newtons, 12 centimeters. So, likewise, according to the scale, extend these lines. Because we know vector is a vector using an arrow is a graphical representation of a vector. Length of the arrow gives us the magnitude, and direction of the arrow gives us the direction. That's the idea of a vector. If this is vector AB, if this is vector AB, the length from here to here, A to B, is the magnitude of that particular vector, and direction from A to B is the direction of that vector, right? So same thing is used. Same thing is used. Then if these two sides are completed, then complete other two sides as a parallelogram. මෙයාට parallel line එකක් මෙතනින් ගාව, මෙයාට parallel line එකක් මෙතනින් ගාව. parallelogram එකක්. මේ දෙක තමයි critical. Right? So once it's done, then finally you can connect the diagonal. Right. Okay, what's the last point we mentioned? Measure weight plans. All right. Okay, next point. What's the number? 6? 5. 0.6. Right. Next point. Mark lengths of OA and OB. I have labeled them here. Mark lengths of OA and OB. Mark lengths of OA and OB. It's coming from. Okay. Mark O and OB. Mark lengths of O and OB according to a suitable scale. According to a suitable scale. As weights and lengths are proportional. Now, as an example, take this down. This is an example. This is not a rule. This is an example. According to your sheet, size of the sheet and the space you have, you can manage this. Right? Take this down as an example. 1 Newton by 1 centimeter. That is an example scale. 1 Newton by 1 centimeter. A possible example scale. Next point. Label this point as C. Okay. Next point. Complete OACB parallelogram. Complete OACB parallelogram. Complete OACB parallelogram. Complete OACB parallelogram. And connect O and C. And connect diagonal O and C. And connect diagonal OC. O and C and connect diagonal OC. And connect diagonal OC. For the same point, measure the length of OC. Measure the length of OC. Right? Measure the length of OC. Right. Next point. Use a red pen and write down with an asterisk mark. Compare the weight, compare the weight comes from scale. Compare the weight comes from scale. Compare the weight comes from scale. Compare the weight comes from scale with the actual weight of with the actual value of with the actual value of T2 with the actual value of T2 with the actual value of T2 and verify law of vector parallelogram. Verify law of vector parallelogram and verify law of vector parallelogram. Right. Okay, now take this down. You didn't take this down, right? Take this down. This one, no? This one. This diagram. This diagram. Only this part, this diagram. Any other questions? So, sir, by looking at OA, we are drawing its opposite side. I didn't get your question. You have to get the direction or the image of the string onto white sheet. Do we need to draw diagram? You asked about that. That's what we are doing now. So what's that? M1G and W. M1G is the weight of the pan. M1G, weight of the pan. See, this is the known weight we have considered, and M1G is the weight of the pan. Weight of the pan. So will you please repeat the point? Sorry, I didn't see which point. So we get down the first step. No, I know you have obeyed the first step. I mean this one. Right? This one. Completing the parallelogram. Okay, what about the ones on YouTube? All good? Any questions? How's your holiday so far? Okay, now the first one is done. Okay, finished? Right. Other than that, there are a few other remarks. Remarks in the sense, important points. Right? So we'll mention some remarks as well. Remarks or important points. Right? So as the last thing, we will mention these things, mention these points one by one. Right? So if you have any questions, ask me meanwhile. First point here, remarks. Drag the center weight downwards. Drag the center weight downwards. Drag the center weight. Drag the center weight downwards and release. Drag the center weight downwards and release, and check whether it comes back to its initial position, and check whether it comes back to its initial position. Right? if it comes back, there's no friction. If it comes back, there's no friction on pulleys. If it comes back, there's no friction on pulleys. Right? If it comes back, there's no friction on pulleys. If not, apply some lubricant oil. If not, apply some lubricant oil. If not, apply some lubricant oil to pulleys and reduce friction. Apply some lubricant oil to pulleys and reduce friction. Right? Second bullet, second point. If strings have a significant weight, if strings have a significant weight, if strings have a significant weight, it decreases the accuracy. It decreases the accuracy of experiment. 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 It decreases accuracy of experiment. Therefore, it is recommended to use thin, light strings. 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 Right. Next point. Add weights of pans. Add weights of pans to known weights to increase accuracy and have better results. To increase accuracy and have better results. Okay. Again, look at the board again. Now, vector parallelogram is verified. Right? Listen, vector parallelogram is verified. Now, if this is verified, we can use the same setup to determine an unknown weight. Right? That is the next step of this experiment. Right? Look at the board. Now, that is why we have this. Yeah. A small stone or a glass stopper. Small stone means that's an unknown weight. Small stone. Stone glass stopper as long as you can hang it from the string here, you can measure it. Right? So we'll take a small stone or a unknown glass stopper. Unknown means we don't know the weight, we haven't measured the weight using triple beam balance. Right? And then you are replacing this W2 with that unknown weight. Right? Look at here, look at the board. The last part, final part of the experiment, we are replacing this with the unknown weight. Let's say mg. We are replacing that with the unknown weight. And you can do the same again. And then again you will get another diagram. Let's say now in that case, this is OA dash and this becomes OB dash. You will get another parallelogram like this. Now tensions will be different. Why? Tensions are different because weights are different. Tensions are different, which means lengths are different, and your parallelogram will be different, right? Everything will be different. And then complete this again. Let's say C dash, right? And now this is again a system in equilibrium. So therefore, if you measure the length from here, let's say R dash gives us the unknown weight. Equilibrium में क्या So likewise, unknown weight can be determined, right? Very simple. Now, if that is verified, determining an unknown weight is just one step away. Right? Okay. As the next thing, write down determination of an unknown weight. 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 Determination of an unknown weight using law of vector parallelogram. Using law of vector parallelogram. Using law of vector parallelogram. And one more thing, you have to follow the same scale when you draw the second parallelogram as well. The scale you have to follow the same scale, right? I'll say here you got a length of 18 centimeters, then there is 18 newtons, likewise, right? Okay, write down below. Replace weight W2. Replace weight W2 with unknown weight within brackets mg. With unknown weight within brackets mg. And repeat the experiment. And repeat the experiment. To construct and repeat the experiment to construct O A dash C dash B dash parallelogram. O A dash C dash B dash. O A dash C dash B dash parallelogram. And measure diagonal OC dash. 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 Next point, using the same scale, determine the unknown weight. 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 Right. Okay. And take this down. This diagram, second parallelogram. Take down the second parallelogram. Okay, so that's the end of practical 1, experiment 1, right? Any questions before moving on to the next one? So will you repeat the last point? Very good. Yeah, it's good to see that you have you are sharing the note and everything among your friends. That's good. Right. What else? So, sir, the points you gave together is for both the parallelograms. You mean under method 1? You mean under method 1 under method 2 points? Remarks. That's overall. That's overall. Same thing. We are repeating the same. Same thing. We are repeating the same. Any other questions? Clear? Clear? Okay then. Okay. Right. So you can read what is given in the tute later, right? So as I told you, that is just a summary of this is given there. That's just a summary, right? Refer this as the main note because here I have explained to you everything you need to know, even without missing anything, right? And in the last page, I have mentioned the past paper questions which has already come from these ones. So later on, you can try them. The last page, yeah. Parallelogram 2005 and 2022. Right? So after the session, you can try writing answers for those questions as well. Right? Arne? Next one. Right. Okay, let's go to the next one. Right. Practical 2. Next one. Practical 2.